This is parts of similar triangles. This is once again the same type of stuff that we've been doing. It's all about setting up proportions and solving for our missing variables. Okay? That's the same thing we've been doing. Now we just know that we can also do this with similar triangles. So there's a whole bunch of theorems and definitions here, but all the theorems are telling us are that there are other proportions we can set up if two triangles are the same. That's the only thing that it's telling us. So, proportional perimeters theorem. Well, what does the perimeter mean? What is perimeter? Yeah, the overall distance around it. So that means if we have two triangles that are similar, then the perimeters are proportional to corresponding sides. So not only can we set the sides up being proportional to each other, if we know the perimeter of one, we can set the perimeters up to be proportional. Okay. The next one, if two triangles are similar, then the altitudes are proportional. Well, what's an altitude?
You know.
Well, I know. Do you know?
Would it be how high it is?
Yeah, it's the height. So it's the one that makes the 90-degree angle. Okay, that's our altitude. So if we have two triangles that are similar, we can set up proportions with the altitudes. Okay. The next one, if two triangles are similar, then the angle bisectors are proportional. Angle bisector, what's that? We've learned that word before. Bisects what? Bisects the angle. What does it mean to bisect the angle? Cut it in half. So those two angles would be congruent. So if we see that we have angle bisectors, we could also use that length of the angle bisector in our setups for the proportionality. And the last one here is the similar for triangles, and the medians are similar. Median, this one is probably new for you. But the word median, what does the word median mean in math?
It's half of whatever the base is.
No, that's midsegment. Midsegment is half of the base. Median, what does the word median mean? Like mean, median, mode? Is the what? Yeah, it's the middle, okay? So median in the triangle is also the middle, so it's going to go to the vertex, to the middle on the other side. So that's our median. So if we see that on our triangles, we also have things proportional, okay? So that's all this unit is adding on, is not only are similar triangles proportional, but now we have all these other segments of triangles that we can also make proportional. So if we see altitudes, if we see angle bisectors, if we see medians, if we see the perimeter, we can use all of those to set up our proportions as well. Okay. And then I just put on here the angle bisector theorem. The angle bisector separates the opposite side into segments that have the same ratios. So our angle bisector, we can also set up ratios between here. So we can also say if we have this angle bisector, 4 over x is equal to 6 over 2. So it also splits it up that way for us. So let's get into some examples here. So here we have this diagram. Okay, we got two triangles. And we are told that A, B, C, and E, F, G are similar to one another. Okay, so we know that they're similar. We are told that AD is an altitude and EF is an altitude. Oh, it's all connected. So we want to find X, and then we're given some other measurements here. So what should we probably do first with these other measurements that we're given? Put them in. Okay, so find X. So EF is 36. Okay, so let's put EF on there. EH is 18. AB is 56, and our X is going to be right there on AD. All right, so what type of proportion can I set up here to solve for X? Okay, so 18 over X equals 36 over 56. Are there other ways you could set this up? What's another way you could set it up? What did you start saying, James? Yep, 18 over 36 equals X over 56. Same thing. Okay, that also works. So now how can I solve this? Okay, so 36X should equal, what's 18 times 56? What? 1008. Okay, then how do we get X? $28? All right, so our value for X here is 28. Is that okay? It really is the same concepts we have been doing. We're just, we just now have some other segments we can use with it. Okay? Let's look at another one. Are you using your calculator? These two triangles are similar. Okay? We are told that BG is a median of ABC and EF is a median of DEF. So all that tells us is that these medians we can also use in our proportions. So here we want to find EH, and we know BC, BG, and EF. So let's start by labeling. So we want to find EH, so I'm going to label that one our X. BC is 30, BG is 15, and EF is 15. X over 15 equals what? What did you say over 30? 15 over 30, yep. Okay, so how am I going to solve this? Okay, so 30x is equal to, good, 225. 7.5. So X is 7.5, which is our EH, which is what we were asked to find. Is that one okay? Well, this one said find EH, so I'm going to label it as EH. All right, let's look at another one. Oh, this one we got two on here. So for the following examples, find X. So we know that the two triangles are similar. When we're given two triangles, we just have to set the proportion up correctly. So what would be a proportion that would work for problem 3 up here? X over 6.5 equals what? Yep, 12 over 13. So 13x should equal, what's 12 times 6.5? 78 divided by 13. X is 6. Is that okay? All right, and last but not least, number 4. Yep, 9 over 24 equals X over 18. 24x is equal to, what's 9 times 18? 162. We divide by 24, and what do we get for our X? Are those all okay? I mean, they really are the same exact type of thing as we've been doing. We're just adding more segments onto it. Mm-hmm. So if you had 9 over 18, no. You could instead, you could certainly, so if you use, we use the 9 and the 24 here. So if we use the 9, then the x is the one corresponding with it, so that has to go on the top, and the 20 and the 18 would have to go on the bottom. Now let's say instead you did 9 over x. So if you did 9 over x here, then you'd have to say 24 over 18. No, it does not matter where you start from as long as you keep them in the corresponding parts. Okay? All right, then we got one last example. Find the perimeter of triangle ABC if triangle ABC is similar to triangle DEF and the perimeter of triangle DEF is 60 feet. So, we also know the perimeters are proportional. So we're going to do the same thing we have done. We're just going to now include the perimeter. So what's the one proportion that we know from here? We know what sides do we have corresponding? 5 and 9. So we know 5 over 9, right? Which triangle are we trying to find the perimeter for? ABC. And that's our one with 5, so we'll put the x with the 5. And then what's the perimeter of DEF? 60, so we'll put the perimeter of DEF with our side that came from DEF. So 5 over 9 equals x over 60. So what does 9x equal here? 5 times 60? 300. That sounds much better. Then we divide by 9. So what's our x? So 33 1/3 is our perimeter of triangle ABC. Okay? The perimeter ones are probably going to be the ones that hang you up the most. All right? Because it's not a side over a side equals a side over a side. It's a side over a side equals the perimeters related to each other. And the perimeter problems are the first ones on your assignment. Okay, so that's why I wanted to do that last for example, so hopefully it's the freshest in your mind.
320 to 321, 10 to 15, 19.
So page 320 to 321, 10 through 15, and 19 through 25. It's going to be due for tomorrow.